Hello, my name is Stefon Johns, and this is my dimensional modeling briefing for Oregon Health and Science University. To begin, we first need to have a definition for dimensional modeling. Kimball and Ross define it as a technique for presenting analytic data that addresses understandable data delivery and fast query performance. In short, dimensional modeling is intended to make databases simple. With that definition, we then begin the dimensional modeling process that involves 4 key steps. As described by Kimball and Ross, these steps include defining the business process, declaring the grain, identifying the dimensions, concluding and identifying the facts. As OHSU is a multidisciplinary company, meaning that multiple services are offered, we intend to focus on just the healthcare division today. The first thing we need to do is identify our business process. For the purposes of this demonstration and briefing, we're going to be using patient encounters. Within the healthcare division, there are many different events that generate metrics that are valuable for one department or another, but the first and most important critical event is the patient encounter. The table that you see on your screen is an example of the data collected during this workflow. As shown, the patient encounter records several pieces of key data that are vital to making sure that everything stays cohesive between departments. If we take this data, we can then discover the grain of our model. Kimball and Ross state that a grain should be equivalent to 1 row in the fact table. In our case, the grain is a single patient encounter line item. In identifying the grain as such, we can see that the business requirements of this process fall in line with the data collected. From there, our next step is to identify the dimensions. We see that the dimensions we can pull out are as follows: patient, date, physician, intake employee, diagnosis, and facility. Each dimension corresponds to a separate fact table that relates to this process. Moodley states that dimensions can be easily identified if the grain is clear. From there, we then are able to identify our fact table. Here we see that we have our patient key, intake, employee key, physician, date, facility, diagnosis, and then an encounter ID. This is what we would technically call a transaction fact table. Kimball and Ross state that a row in a transaction fact table directly corresponds to an event in time and space. With the patient encounter process, it uses not only a date-time measurement, but also a location measurement in the form of the facility key. As the data for patient encounters is multidimensional, we can aggregate this data by date, physician, and even patient age using OLAP. OLAP is known as Online Analytical Processing. Using this software would be useful for business end users who want to see something like the number of patients a physician sees in a specific time span, or the age band of patients, or even to understand the number of visits the ER gets every year. This is most often associated with a star schema in databases as depicted in the first slide. However, there are alternatives, according to Harris, that an organization should take into account. The first being data lakes, the second, HTAP, and the third, self-service tools that act as OLAP analysis. As previously stated, the patient encounter uses a star schema to represent the dimensions of the database. This schema ensures that each fact table has only one set of dimensions. With the simple data provided, we see that there are no foreign keys with any of the dimension tables. If there were, it would be my suggestion to use a snowflake schema. A snowflake schema is an extension of the star schema, but it adds additional dimensions. For instance, if the facility dimension were to contain a foreign key to another dimension table, a snowflake schema would best illustrate that relation. In addition to these two schemas, there are star cluster and galaxy schemas. Galaxy schemas use more than one fact table typically two, that have shared dimensions between them, while a star cluster schema is a balance between a star and a snowflake schema, in which overlapping dimensions are found as forks in the data hierarchy, which are then classified with a one-to-many relationship. While this plan is meant for implementation within the patient encounter business process, this can be applied to several other processes within the healthcare division of OHSU. In following the steps for the dimensional design process as outlined by Kimball and Ross, OHSU will be able to effectively identify business requirements, improve patient outcomes and care, and collect, analyze, and share meaning and insights throughout the healthcare division. Thank you for watching, and I hope that you gained some insightful information from this presentation.